Okay, hello. So as we talk about it, our target this week is to finish this chapter 2, the notion of the determinant. Okay, so I'll give you some idea tonight. So what I'm going to do, I'm going to give you a couple of more, okay, just give you quickly some idea of the property of the determinant that will enable us to finish this chapter, okay. So I go over the section 2.2. We have 2.2 and 2.3 to get this one done. So let's see what's going to be on 2.2. There are some interesting property that if you know it, that will help you quite a lot to be able to find the determinant of a matrix. And there are a couple of more properties of a determinant as a function that's going to be very useful for the future considerations, okay? So we are going to check this section 2.2, some nice property of the determinant, okay? So this is what we're going to do. What happened to this camera? Okay. Okay, now we get it. Okay, we talk about determinant the other night. Okay, like a function that's going to be a number that we assign to a matrix. And in order to find that, this property would be very useful. So we are going to check properties of a determinant. Okay, determinant of a sorry, of a matrix. You know that you have to have the square matrix. So suppose these matrices that I'm going to talk about are all squares. The first one is a very obvious one, but very useful. You see, we talk about it. When you want to find the determinant of a matrix, you can distribute on one row or one column. So we can use the row and the column and we arrive at the same answer. So that will tell us that the determinant of a matrix and its transpose are going to be the same as each other, okay? So this is property number one. If A is, of course, a square matrix, okay, it's going to be a square matrix, then, okay, then the determinant of the A. So the det of A is the same as the determinant of its transpose. Would be very useful in future. We're going to use it. Again, the reason is that it doesn't matter that you start with a row or you start with a column. Remember, we expand a kind of a dot product of the vectors on one row or one column. So the result would be the same. Okay, so that's going to be the first one, the obvious one. The second one, if one row or one column of a matrix containing zeros only. Okay, if you have a zero row or a zero column. So we can distribute, the definition of a determinant through that row on or column. So the determinant would be zero. Okay, so the next one is if A has a row. Okay, if has a row or a column. Okay, has a row or a column of zeros, all zeros, then it's clear that the determinant of A would be zero. Okay, because all the entries of that row is zero, and that make it the determinant equal to the zero and beta. Okay, so it's the second one. The third one, and the third one is if two rows of if you have two identical rows equal to each other, or two identical columns, the determinant would be zero. Okay, so if A has two identical, the same as each other, okay, two identical rows, again, or columns. okay, or columns, then the determinant of A is going to be 0. Okay, so if you get all zeros, the entry is 0, the result's going to be 0, or you get two identical rows or two identical columns. Because we can use the kind of row echelon form. When they are identical, you subtract one from the other one, so you get a new row containing all zeros. Okay, that's going to be number 3. Number 4 is going to be interesting. We are going to use it from time to time. You see, sometimes you may have to multiply in the terms of a matrix by a number k, or sometimes you may have to divide it. So we want to know what's going to be the result, the determinant, the resulted, okay, what's the determinant of the resulted matrix. So this is going to be this one. Suppose B is going to be the resulted matrix. So B, if B is going to be the matrix, okay, it's going to be the new one, metric obtained. This metric obtained from A by multiplying or dividing, okay, by multiplying a row again or a column. Because of that property that we have, every time we talk about the row, we can switch it into the column too. Okay, by multiplying a row or column, okay, or column of A by a number, by a scalar k. Okay, multiply by 2, multiply by 3. And then remember the B is going to be the resulted matrix. The determinant of the B, the resulted one, is going to be equal to k times the determinant of A. Okay, so if you multiply by, okay, if you multiply the terms of the one row or one column of your matrix, one row or one column of a matrix by k, then the determinant would be, okay, determinant of the result is going to be k times the original one. Okay, and sometimes you can switch this one. You can find the determinant of the A. So this means the determinant of A is going to be a smaller, is going to be a portion of the determinant of the determinant of the B. Okay, so what does it mean? So equivalently, this is what its meaning. Equivalently, this means if you want to find the determinant of, okay, determinant of, so this is when you multiply by only one k, if you like. So if you want to find the, let's say, not equivalency or, okay, let's say consequently, or let's say note that. What I want to tell you that, you see, in this case, you just multiply by, if you multiply one row by k, that gives you k depth of A. So if you multiply two rows by k, so that gives you k squared. So if you multiply all the rows of a matrix by k, okay, so if you want to find what is the determinant of the k times A, remember when we multiply a matrix, when we multiply by a metric, what you do is we multiply all the terms inside by the k. So you multiply the first row, the second row, the third row. How many rows do we have? N rows. Anytime you multiply by one number, you see your result is going to be k times third of A. If you multiply by, okay, if you multiply two rows, that give you k squared, k to the third, k to the fourth. But your matrix would have n rows. So this is going to be equal to the k to the n times determinant of A. It would be very useful formula in future, and we are going to use quite a lot. Okay, so I repeat it again. If you only multiply one row or one column of a matrix by K. So the determinant of the resulted matrix is going to be K times the original one. Or the determinant of the A would be 1 over K of the original one. Okay? But if you repeat this one, repeat it for each row of your matrix, so the determinant of the resulted one, the determinant of the K times A would be K to the N that of A. Where is N? N is, okay, where A is an N by N matrix. This would be very useful. Usually give you one problem and we check all of them. Okay, what's going to be the fifth one? The fifth one is the one that we are going to use for the row echelon form. Sometimes you know that you add or subtract two rows. Sometimes you multiply one row by a number, you add it with the other one in order to get to the row echelon form. And this type of operation is not going to be changed the determinant at all, okay? So this is going to be if B is going to be a matrix, if B is a matrix obtained from A, okay, by let's say multiplying by if you like adding a multiple of a row or a column, okay, or a column of A to another one, like the operation that we use to get the row echelon form. Okay, you multiply the first row by 2, you add it to the third row. Okay, if you do this one, everything will stay the same. Then the determinant of the B, the resulted one, is the same as the determinant of the A. So we try, when we want to get to the row echelon form, we try to use this operation all the time, because this operation won't change the determinant of the A. Okay, if you just multiply by a number, okay, if you multiply your determinant by 2 or by 3, your matrix by 2 or 3, you see the result would be different. The determinant of the resultant matrix would be different. But if you do this combination of the operations, the determinant of the B would be the same as the determinant of the A, okay? So very useful one. Determinant of the transpose and the matrix, both of them are the same. If one row contains all zeros, it's clear that the determinant would be 0. If you have two identical rows on column, we can use, we can subtract the two rows and get 0, 0. The determinant would be 0. If you multiply one row by a number, if you multiply one row by K, it's like factoring out. So the determinant of the result would be K times the determinant of the A. But if you do this one to all the rows, okay, if you do it to all the entries, the determinant of the resulted one would be K to the N determinant of the A, when N is going to be, okay, N is going to be the matrix is going to be N by N. And if you do those type of row echelon form, okay, you multiply one row by 2, you add it to the other one. So the resultant matrix would have the same determinant of the other one. Okay, so that's one. Usually check this one with one question. You have a couple of them in your book, and you are going to see one in your next practice one. Okay, so pay attention to this type of example. Okay, that's it. All the possibilities, I'll give you all of them here. Now, if you are going to suppose a matrix is given to you, okay, suppose A is going to be a 3 by 3, okay, a 3 by 3 matrix. A 3 by 3 matrix, and we know that determinant of the A, okay, determinant of the A is given to is a -4. They ask you to find each of the following, okay? Find each of the following. give you a couple of format. That's it. The first part, they ask you what is the determinant of the 2a, and you multiply all the entries by 2. Okay, the second part, they ask you what is the determinant of the, okay, what is the determinant of the negative a, and the third part, they ask what is the determinant of the a transpose. Okay, so you have to use that property that we talked about it. Okay, are you ready? Solution. The first one, you know that if you multiply a matrix by a number, it's a 2 times a. Okay, now it's going to be equal to, you see, when you multiply by 2, this means you multiply all the rows by 2. So you check to see how many rows do you have. You have 3 rows. If you multiply only the first one, you know that this would be 2 times that of a. If you multiply by the second one, it's going to be 2 times 2. Then if you multiply all of them, it would be 2 times 2 times 2 times 2, which is going to be 8. Okay, so this is going to be 2 cubed because n is equal to 3. 2 cubed times determinant of a. 2 cubed would be 8. Determinant of the a is given to is a negative 4. So the result would be negative 32. So the determinant of 2a is going to be negative 32. Okay, so I use this formula. You see, I use this one, that determinant of k times a is k to the n, determinant of a. Okay, so it depends on the size of a matrix. Okay, any question? That's going to be the first one. So let's go to the second one. What's going to be the second? Second one is very a special case of this one. You see the determinant of negative a. You see negative a is like negative 1 times a. So k is a negative 1. So this is going to be negative 1 to the, okay, negative 1 to the n, negative 1 to the third. Negative 1 to the third times determinant of a. Determinant of a. Negative 1 to the third power would be negative. Determinant of the a is negative 4. So the answer would be 4. Okay. So this is the formula that we use. You see, if you have a determinant of a negative a in general, and if this is going to be negative 1 to the n, that's of a. Okay, this is a nice formula. Of course, a is, in this case, is an n by n matrix. Okay, so that sign is like a k. K is negative 1. So you have k to the n in general. So in this case, it's going to be the very, very special one. Okay, we are going to use this one when we get to chapter 5. All these formulas, after especially this determinant, are going to use 3 places. So you will see this at the end of the course. Okay, so this is going to be number 2. Of course, number 3 is easy. Okay, the number 3 is just, they ask for the determinant of the A transpose. Okay, so we know that the determinant of the A transpose, you see the determinant of A transpose, of course, is the same as the determinant of the A, because we can find the determinant using the row or we can use the column. But determinant of the A is negative 4. So in this case, the determinant of the A transpose is equal to negative 4. Okay, that gives an idea of the way we are going to use it, especially in future, quite a lot. We get through this one. Okay, so this is one application. The other application is sometimes use this property if you want to find the determinant of a kind of complicated matrix. Okay, so give an idea how we're going to apply it. Okay, so that's the option. You can use the determinant always just using the original formula. But just then you can have a look to see, you may see something interesting, okay, for these matrices that we're going to have. So what's going to be the other example? Example is we want to evaluate. Okay, that's it. We want to evaluate the determinant of each matrix. The determinant, okay, determinant of each matrix. Each matrix. Let's see what type of matrices we are going to have. Okay, let's take the first one. What's the first one? The first one is a kind of 5 by 5 matrix. Okay, let me finish it. Let me explain it. So this is what we have. We have 2, 1. Okay, 2, 1, 3, 2, 1, 3, and that's going to be K 4, 2, 4, 2, and this is going to be 6, 6, 2, 6, 2, 1, 4, 1. Okay, then you have a 6, 3. You have a 6, 3, 9, 12, 6. Okay, and then we have a 2, 1, 2, 1, 3, 2, 1, 3, 4, 1, 4, 1, and then get a 1, 4, 2, 1, 1. Okay, this is the matrix A, and we want to find the determinant of this matrix. Say if you want to do it the right way, it takes quite a while to do it, because you see you don't have lots of zeros so that you'll be able to just expand it. So check to see if there is any relationship between these rows. You see, that's it. You look at this one. This is a 6, 3, 9, 12, 6. And this is 2, 1, 3, 4, 6. So for example, if you multiply this one by 3, if you multiply by 3, that gives you 6. Okay, that is going to be, and that gives you 3. Okay, and the 3 times 3 would be 9, 3 times 4 would be 12, 3 times 2 would be 6. So in this case, both of them are going to be the same. And if the two rows are going to be identical, the determinant would be 0. Okay, so what we're going to do, we are going to change this one a little bit. Okay, so we would like to change the R into, okay, R into the 3R1. That's your intention. So for this intention, what you are going to do is you are going to find, to multiply this one by 3. You know that when you multiply by 3, okay, when you multiply by 3, so the determinant of the matrix would be multiplied by 3 too. So your A is going to be, you see, if this is going to be the case, then the determinant of the A, okay, so I'm going to write it down here. So the determinant of the A would be equal to, you see, we talk about it. If you multiply it by, this is going to be the case that we're going to have. Okay. So this is the one that we're going to use. So it's like, you know, this is going to be the result. If you multiply the matrix A by K, the determinant of the KA is going to be 1 over K of the resulted one. Okay. So it's like, to remember it, you see, since you multiply that one by 3, so it's going to be 1/3. Okay, it's like you put the 1/3, you see, you put the 1/3, and at the same time, you are going to multiply this one by 3. You see, it's like 3 over 3, which is equal to 1. Okay, if you multiply by 4, you get a quarter, because it's like factoring out and simplify it. You see, when I multiply this one by 3, that gives me 6. That gives me 6, 3, 9, 12, okay, 12, 6. You see, if you factor out the 3, 3 and the 1/3 would cancel out. And that give you, that give you the original matrix. So this is the way we are going to write it down. As soon as you multiply the inside by something, So you have to divide outside at the same time so that your determinant would stay the same. Okay, so 3 by 3, that's it. So if you write the other part, quickly you find out that the determinant would be 0. That's 6, 2, 1, 4, 1. Now this is going to be 6, 3, 9, 12, 6. And the rest is going to be 2, 1, 3, 4, 1. Okay, 4, 1. And the last one is going to be 1, 4, 2, 1, 1. Okay, now you have two identical rows. This is it. One row is this one. Okay, and the other one is this one over here. So two rows are the same. So the determinant of this matrix would be 0. So that give you what? It's going to be 1/3 times 0, which is equal to the 0. So the determinant of the matrix A, is equal to the 0. Okay, so quickly you should, they give you a hint, they say use property of the determinant to find the determinant of this matrix. So there must be something, something in between that you should be able to take care of it. So in that case, we're just looking for the two identical row, and we have to multiply by 3. It's no big deal. You multiply by 3 at the same time, you divide by 1/3, so everything stays the same. But the resultant matrix is going to be something nice. It would be something that you get two identical rows, so your determinant would be 0, and you're done. Okay, so that gives you the first one. And the one that we are going to check these properties in 1 or 2 questions on the test. I already given you the first one. This is a second one. So what is going to be this one? Look at this matrix. You begin the matrix A is equal to, it's a 3 by 3, so it's going to be 1/2. Okay, we have the 1/2, and this is a -1 minus 1/3. Okay, so that's going to be 3/4. It's going to be 3/4, and this is going to be 1/2, and this is a -1, and I have one -4 and 1. So you want to find the determinant of this matrix. Okay, we can use the original method and evaluate it, but we want to make it a little bit simplified, okay, easy, because we don't like fractions. Okay, if you don't like a fraction, you can get rid of this fraction. Now, how are we going to get rid of this fraction? You see, to get rid of this fraction, you have to multiply everything by 6, common denominator. Okay, so this is the first row. You want to change it to the 6 times, okay, R1, and you have some fractions over here, so you don't like the fractions. So how about multiplying by, okay, you are going to multiply this one by 4. Now, what is going to be the result for the determinant? It's like multiplying by 6. So at the same time, you have to divide by 6. So 1, 6, and 6 would cancel out. Over here, you multiply by 4. So your determinant would be, okay, 4 times if you like. So to take care of it, you have to divide the outside by 4, okay? 1/4, 4, 1, 6. So this is going to be the result. So this is the original determinant. So you change it. You want to multiply by 6, so divide the outside by 1/6. They would cancel out. You want to multiply this one by 4. Okay, so divide the outside by 1/4. So it's going to be the same as the determinant of this matrix. We know that. It's just vertical line. This means the determinant. So what's going to be resultant matrix? If you multiply this one by 6, that gives you 3. Okay, that gives you a -6. And this is going to be -2. If you multiply this one by 4, that gives you 3. By 4, that gives you 2. Okay, and by 4, that gives you a -4. Okay, -4, and this last one would be unchanged. You see, no fractions. Okay, we get no fractions over here, and it's not a big deal. You can find the determinant of this matrix. You can simplify it a little bit if you like, but you can find the determinant of this matrix and just put them together. So this is going to be what? This is going to be 1 over 24. Remember, it's a 3 by 3. Just expand it. Okay, don't bother. You can simplify it further, but your job was to get rid of these fractions. Okay, so this is it. I'm going to expand it over the first row, for example. It's going to be 3 times. You see, eliminate the first row, first column. So that gives you 2 minus, okay, it's going to be minus 16. Then it's going to be minus negative 6. Remember, positive, negative, positive. So eliminate the first row and the second column. So that gives you a 3 minus a negative 4, make it the positive 4. Okay, and finally plus a negative 2 times eliminate. So that gives a negative 12, negative 12 minus minus 2. Okay, as I told you, you can simplify it further or just find the result. So what's going to be inside? Inside this is going to be negative, okay, that's a negative 14. Negative 14 times 3 would be negative 42. Okay, that would be a positive, and this is a 7. Okay, so that gives you a positive 42. And over here, this is going to be a negative 14. The negative 14 times a negative 2 would be a positive 20. Okay, a positive 28. So these two would cancel out. So you get the 28 over 24. You can simplify it by 4. That gives you 7, 6. So the determinant of your matrix, okay, the determinant of A would be 7, 6, and you're done. Okay, so this is a kind of operations that that you can apply to get these okay, to get these nice results. Okay, so I give you another one to see how we can you see, if you can avoid these just multiplying, dividing, just staying with the operation of adding 2 rows or 2 columns together, a kind of row echelon type. So the determinant stay the same all the time, you see. So I'm going to give another example of this format that would be useful for the row echelon form type problems. Okay, let's see how we can simplify this matrix. Okay, we are going to have a 4 by 4 one. So this is a 4 by 4. It's a 2, 5. Okay, 2, 5, negative 3, 2, 5, negative 3, and then negative 2 I have here. Okay, then I have a negative 2, negative 2, negative 3, and the 2 and the negative 5. Then I have a 1, okay, 1, 3, negative 2, 2, and this is going to be negative 1, negative 6, 4, and 3. See, this is another matrix. And if you like to get a determinant of this one, you think about it, you can change it to the rational form. Okay, that give you something easy to work with, or you can easily, okay, easily you can create a row or a column with lots of zeros. Look at this one. You see, if you add these two together, so if you have the R1 into the R1 plus R2, this would be 0. Okay, this would be 0. Then we can make this one into the 0. You see, add it to the twice of. And when you do this type of operation, the determinant would be stay the same. Okay, 2R3. So I got the 0 here, I got the 0 here, and I can get 0 here if I just add it, okay, add the R3 to the R4. And these operations are going to be free. The determinant is going to be the same when you do this, okay, adding, subtracting the row and the column. So the determinant of the original one and this one would be the same, and that would help you quickly to be able to find it. Okay, these are just a suggestion that that you may get it when we get to these type of matrices. Okay, so what we do, we say, oh, the determinant of the given one is the same even if I do this type of operations. If you do this column would be 0, I'd write the result. Okay, so this would be the determinant of the A would be the same as the determinant of this matrix. So when you write this one as a vertical line, means you mean the determinant. Okay, you add R1 and R2. If you add them together, see R1 and R2, that give you 0. Okay, 0, 0, 2, -1, -7. Okay, 0, 2, -1, and -7. Done. The next one, R2 and the 2R3, 2R3, that give you 0. 2R3 make into the 6, so we get a 3. Here, 2R3, that give you -4, make it into the -2. And 2R3 is going to be 4, is a -1. You see, that's the case. Now here, R2 and R3 together, R3 and 4, 0, -3, 2, 5. Okay, that's it. And the last one unchanged is the -1, -6, 4, 3, 4, 3. You see? We easily find a nice column. So we can extend it along this column. Okay, everything is 0. So we pick only one, this number. This number is going to be, okay, so it's going to be equal to, remember those Cij that we talked about it. So what we are going to do is we are going to eliminate this column and this row, if you like. So the entry is a -1. The sign, remember the sign is -1 to the I plus j. I plus j, where are you? So we are on the fourth column, this -1. Fourth row, first column is going to be 4 plus 1. To make sure you get these positive numbers right. Okay, remember that was -1 to the I plus j plus what? Plus Cij. What is Cij? Cij is going to be a matrix that resulted by eliminating this row and the column. So the resulted matrix is going to be this one. Okay, it's going to be a 3 by 3 one. So eliminate this row and the column. So what's going to be the result? We're going to 2, -1, and -7. Okay, 3, -2, -1. And then we get the -3. Okay, -3, 2, and 5. 2 and 5. This is going to be the new determinant. Okay, I eliminate the first column and the last row. So this is going to be the leftover. To determine the sign, I see this -1 is just the entry, and the sign is always -1 to the I plus j. -1 to the I, the fourth row, the j, the first column. Now this would be 5, -1 to the fifth to the negative, and it would be positive. So you will lose all of them. So it is going to be equal to, okay, I'm going to go to the next page to continue. Okay, this is the one. So these numbers would be positive because it's a negative and the negative. So I have to find the determinant of this matrix. So it is equal to the determinant of this matrix. It's a 3 by 3. You can use the formula and get rid of it right away, or if you like, you can go on. It's a 3, -2, -1, okay, and the -3, 2, and 5. See, we can find the determinant right away, but look at this one. If you add these two together, you get more zeros because these are going to be 0, 2. So why not? We are going to do this operation before, okay, getting the determinant. So this is the R2. We write the R2 and the R3, we add them together, and we know that determinant would be unchanged. So this is going to be equal to the determinant of, the first one's going to be unchanged, the -1, -7. Now if you add these together, you say 0, 0, 4. And then you get -3, 2, 5. See? This row contains more zeros, so find the determinant, distribute it in this part. Okay, so determinant would be, your determinant would be equal to what? Is equal to the 4, the sign, negative 2 what? Negative 2, you are on the second row, plus the column, third column. Always for the signs is the negative 1 to the I plus j. I is the row, j is the column. You are on the second row, third column, an entry of 4. Then the result is going to be the resulted matrix. You eliminate the second row and the third column, so the leftover is going to be 2, negative 1, negative 3, 2. Easy to find. Okay, 2 plus 3 would be 5, negative 1 to the fifth negative, so that gives you a negative 4. Negative 4, and just cross multiply to get this determinant. Is a 2 by 2. 2 times 2 would be 4, minus negative 1 times negative 3 would be a positive 3, so this is going to be 3. So it's going to be negative 4 times 1, which is a negative 4. So the determinant of the original matrix is going to be simply negative 4, and you're done. See, very, very easy operation. So knowing this property of the determinant would help you quite a lot to get these true, if you like. And the other option, you have some problems in your book that they ask you to find the determinant of a matrix by reducing to the row echelon form. Okay, that's a little bit tricky. I'm going to show you one to see how we're going to do it, because you have some assignment to do it. Okay, but we give you the option. You see, you can use any method you like for finding the determinant of a matrix. Okay, so let's give you one more example so that you'll be able to solve your. Now you saw it. You saw that this operation, if you keep with the adding, subtracting, okay, your determinant would be the same. And these are the type of operation that you need when you go through reducing a matrix into the row echelon form. Okay, so let's show one of you to see how we're going to operate in case you will see it in your assignment. So we want to find the determinant by reducing to the echelon form. So there you are, evaluate. Okay, we want to evaluate the determinant of the matrix, the determinant of the matrix, the given one, by changing, reducing into the row echelon form. By reducing, it would be useful. Reducing to, okay, reducing into the row echelon form. Row echelon form. Okay, this means, you know, the leading non-zero number would be 1, leading 1. Let's see how we're going to do it. So what's the matrix? It's a 4 by 4 matrix. So A is equal to a 4 by 4, 0, 1, 1, 1. Then I have half, half, 1 half. Okay, then what we have? We have 2/3, 2/3, 1/3, 1/3, and the 0. And we have a negative 1/3, 2/3, 0 and 0. You see that is going to be your matrix. It must be a square to be able to do the determinant case. Okay. So you want to change it to the row echelon form to get the determinant. You must be careful because your operation is you start with the determinant of this matrix and you just keep going. Okay, so you must use the property of the determinant, and at the same time be careful, you may need to do something to get it. Okay, so there you are. What is going to be the determinant of the A? Determinant of the A is equal to, I mean, you can expand it if you like. It's a 4 by 4, it takes quite a while to do it, but you begin the instruction, row echelon form. Okay, for the row echelon form, what we need a couple of, we need a 1 here to start with. This is 0, so we have to switch one of these to get the 1. There is no 1 for each one of them, but we can switch the 1/2 here, the second row, and then we can multiply it by 2 to get the 1. Okay, so your first action is going to be, you have to switch these two together. You know that if you're switching a row, okay, if you're switching 2 rows, then you have to multiply it by a negative 1 when you're switching 2 rows. Okay, I missed this one. Yes, I didn't give you this one. So if we switch, let's go back here. If you have a room, I can add it here. You see the one that we did here. If you switch a 2 row of a matrix, the determinant would be multiplied by a negative 1. Okay, so I'm going to add this one for you because that's important and we're going to use it. Okay, that's going to be the 6th one. So the 6th one is if you interchange, you see if B is going to be the matrix, I didn't write it, yes? No. If B is going to be, okay, the matrix obtained, okay, obtained from A by interchanging, okay, interchanging a row, okay, or a column. Okay, so if switches come, switch one row or one column, okay, then you have to multiply the determinant by a negative 1. Determinant of a B would be negative determinant of D. That's it. Remember, anytime you switch, you multiply by negative 1. So this means if you do it twice, negative 1 times negative 1 would be a positive 1. If you do it 3 times, that will give you to the negative 1. Be careful. Okay, anytime you switch your determinant, you multiply determinant by a negative 1. Okay, so I forgot to give you this one. Now we can go back and apply it here. You see? Remember, we want the row echelon form. For the row echelon form, we have to start with the 1. We have the 0, we switch this to. Okay, so that's going to be the first step. Since you switch it, so the determinant. So what I'm going to do here, I'm going to switch the R1 and the R2. So the determinant of your matrix is going to be negative of the determinant of the new one. It's a 1/2. Okay, 1/2, 1, 1/2. Then you get a 0, 1, 1, 1. And the other are going to be the same. 2/3, 1/3, 1/3, and 0. Okay, and this is going to be negative 1/3, 2/3, 0, 0. Okay, so we switch it so that we'll be able to create the one over there because you need the row echelon form. So what we're going to do is we want to make this one into the 1. So we have to multiply by 2. So you have to change the R1 into 2R1. You know that for the determinant, if you multiply by 2, so what you do is, because your determinant would be twice of the original one. So it's like multiplying by 2 inside and dividing by 2 outside. So this is going to be equal to, okay, it's going to be equal to the negative 1/2. Negative 1/2 outside. Now you multiply the 2 inside. They will make it up. You see, 2 and the 1/2 would be 1. So if you multiply this one by 2, so that give you 1, 1, 2, 1. Okay, and the next one is going to be 0, 1, 1, 1. And this is going to be a 2/3. Okay, a 2/3, 1/3, 1/3, 0. And this is a negative 1/3, 2/3, 0, 0. You see, I got the 1 here. So in order to take care of the other ones, you can take care of this fraction quickly first. You see, to get rid of this row, what you do is R3, you multiply by 3. If you multiply by 3 for the determinant, you have to divide by 3. And then you do the same thing for here. Okay, so you are going to multiply this one by 3 too. So it's going to be R4 is going to be 3R4. So what's going to be a result? So the determinant of the A is going to be equal to already you got the negative 1/2. Then you multiply by 3 here, you have to divide by 3. You multiply by 3 here, you have to divide by 3. You see, now you get your new matrix. So your new matrix would be free of fractions. So it's going to be 0, 1, 2, 1. And that's a 0, 1, 1, 1. Then we have a 2, 1, 1, 0. And this is going to be negative 1, 2, 0, 0. No fraction. Okay, no fraction, and it would be easier to handle to get these numbers. Okay, so far it's going to be 2 times 3, 6, 6 times 3, 18, and then you can work on these columns. You see, this is oh, that was 1. Sorry, this is 1. That's 1, leading 1. Okay, you know that. So you have to make these zeros to make it into the row echelon form. So to make this one 0, this is R3. You can change it into the R3 minus, okay, because this is R3 minus 2R1, okay, to get rid of this one. 2R1 minus 2R1, and to make this one equal to the 0, that's going to be R4. So we can add it to the first one. You know that these operations won't change the determinant. Okay, so you'll be fine. Okay, so R3 minus 2 R1 to get rid of the 2, and R4 plus R1 to get rid of the 1. So then the first column would be out, and then you'll be all right. So it's going to be, okay, going to the next page and continue. Quickly, we get the result. You may say, it's easier for me to just find the determinant, but you've been asked to do it. So you have to follow the instruction, and sometimes it's useful to get it to the row echelon forms. Okay, so the coefficients are going to be negative 18 as we talk about it. Okay, and now those, if you simplify the one that we talk about it, so what's going to be the leftover? Okay, so this is going to be the leftover. The first one is 1, 1, 2, 1. Okay, the second one was 0, 1, 1, 1. Then if you just subtract R3, the one that we talk about it, okay, eventually it's going to be 0, 0, 1, 2, and then this is going to be 0, 0, 0, 3. See, you end up with this one. When you do those row echelon form, you can check it yourself. So we have the leading one here. Okay, this is it, the 1, 1, 1. It's just echelon form, it's not the row reduce, so you don't have to do something else to get it. And now it's easy to find the determinant. So what we're going to do is, this is it. You just use the first column. So it's a negative 1 over 18. Okay, so this is just the first entry is 1. No sign because it's going to be negative 1 to the 1 plus 1. And then you reduce it, okay? So I can write it down for you so that you know what's going on. 1 plus 1. You eliminate the first row, first column. So this is going to be your resulted matrix. Okay, that's going to be 0, 1, 2, and this is going to be 0, 0, 3. Okay, so that gives you negative 18 again, negative 1 over 18. And you can easily distribute it along again the first row, it doesn't matter. Okay, if you eliminate again against this first row, so that gives you what? You see, you eliminated these two. The entry is just 1, so it's going to be 18, and the resultant matrix is going to be 1, 2, 0, 3. So that's going to be negative 1 over 18. Cross multiply, that gives you 3 minus 0, negative 3 over 18, which is a negative 1, 6. Okay, so the determinant of the matrix, original one, is negative 1, 6. Okay, so it's not a big deal. Just skip a couple of places that you have to change the other entry is equal to the 0. It's very similar. You can get to this row echelon form one. Okay, so it is just for you to, when we get those problem in your book, you'll be fine. We are not going to ask you on the test. We are not going to give you instruction. You can do whatever you like to find the determinant that we are going to be interested in. Okay, so this is 2.2, getting through these numbers. What is going to be in 2.3? We get 2 parts. I'm going to give you the first part, and then there is an application. So what is going to be, that take us to the 2.3. So the 2.2 is just really this operational one to get the determinant. Okay, so we can go to this, and there is a, let me see, there's another property of the determinant that we can talk about it here. Then we go to the 2.3. This part again is important for us. Okay, so there are a couple of theorems. You can use it anytime you like, especially this one. So what is going to be this theorem? Remember, we talk about the determinant as a function. And they say the determinant function is multiplicative. Multiplicative means if you wanted to find the determinant of a product of two matrices, it's going to be the determinant of their products, if you like. It's very useful, okay, very useful. So if A and B are going to be, you know that they are a square matrix. Matrices are n by n matrices, then you have this one. The determinant of A times B is equal to the determinant of the A times the determinant of the B. That will help us to get a couple of very nice results. We're not going to prove it, but sometimes we may ask you to verify it by some examples, but we're not going to prove this one. Okay, so it's two matrices going to be determinant of the first one times the second one. Again, very useful for future. So you can use it anytime you like. But the place that we are going to use it is going to be, we want to know what is a relationship. If the matrix is going to be invertible. If the matrix is going to be invertible, then we can talk about A inverse. We want to know what is a relationship between the determinant of a matrix and the determinant of its inverse. This is a conclusion of this result and such an important fact that we are going to use it, okay? So this is the one. What is, okay, so that gives us, see, this would give us the determinant of, let's say, A inverse, the inverse of a matrix. Now, how are we going to find it? Very easy. Look at this one. You know that if a matrix is invertible, then A times A transpose, sorry, A times A inverse would be I, identity matrix. Determinant of identity matrix is just one. So this would be determinant of the A, and this would be determinant of A inverse. So these are numbers. If the product of two numbers is one of them is the reciprocal of the other one. 5 times the fifth would be 1. 3 times the third would be 1. So that's what we are going to use in order to get this theorem, okay? And this is the reason that we introduced that one, okay? So there you are. If, very important, very useful. We have quite a lot of problem dealing with this one. If A is invertible, A is invertible, okay? Then the determinant of the A inverse is equal to inverse of a determinant, reciprocal of the determinant. Remember, reciprocal is a number. Reciprocal of the 5 is 1/5. So the determinant of the inverse is the reciprocal of the determinant of the A. That's it. It's very natural to say that determinant of the A inverse is the inverse of the determinant, but they are numbers. Okay? So, the difficulty is going to be, you know, that this is true if the determinant of the A is not equal to the 0 to be able to do this one. So the conclusion is going to be from here. And so that is important for us. So A is invertible. A is invertible if and only if the determinant of the A is not 0. This is the quickest way to check to see if a matrix is invertible. And we're going to use it quite a lot. Okay, so the determinant a matrix is invertible if and only if the determinant of the A is not going to be 0. This theorem is very easy to prove. It's this one. Just write it down for you so that you see the connection. You see the proof. This is going to be the case. We say that if A is invertible, suppose A is invertible. Okay, invertible. If it's going to be invertible, you know that, then what's that? A times A inverse is equal to the I. Identity matrix, remember? 1, 1, 1, 1, 1 on the main diagonal and 0 everywhere else. So if you take the determinant of both sides, okay, so what is going to be the determinant of the both sides? Determinant of A inverse is equal to the determinant of the I. But we talk about it. Determinant is multiplicative. So this is going to be that of A times the determinant of the inverse. Remember, they are numbers. But this is equal to 1 always. 1, because I is what? It's 1, 0, 0, 0, 1, 0, 0, 0, 1. So the determinant is 1 always. Now these are numbers. Okay, the product of two numbers is 1. So this means, okay, this means the determinant of the inverse is equal to 1 over the determinant of the A. Okay, that's 1. Of course, when we write it down, we know that this is determinant of the A is already non-zero. Otherwise, we cannot have it, okay? So that's very interesting result. And it's the only reason that we talk about that, okay, that multiplicative property of a determinant. And so it's very, very useful, and we use it from time to time. So you may be asked, you see this example, you may want to check to see if a matrix is invertible. So they ask, you do it yourself, of course, but they may give you this hint, use determinant Okay, use determinants. Okay, or to decide, if you like, to decide whether, okay, whether the matrix, is invertible. This is one way to do it, quickest way to do it. You always check this one because that's easy. Okay, this is a matrix. The matrix is 2, 0, 3, 0, 3, 2, and the negative 2, 0. Okay, 0, negative 4. That's it. It's easy to find the determinant. You don't need any lots of properties to do it. Okay, just do it as usual. You can do any row, any column. It doesn't matter really. So the solution is going to be just checking the determinant. That of A is equal to, different way to find it, just go with this one. Okay, I distribute it here, so it's going to be 2 times. Okay, 2 times the determinant of a resultant matrix, element row column, so that gives you negative 12 minus 0. The second one is 0. Okay, nothing here. Okay, 0, and then plus 3 times. Okay, eliminate the first row third. That's going to be 0 minus, that's negative 6, make it to the positive 6. So the determinant of A is going to be negative 24. Negative 24 plus 18. Okay, plus 18, which is equal to the negative 6. Okay, negative 6 is not 0. Negative 6 is a non-zero number, so according to that theorem, A is invertible. A is invertible. And then with that. Okay, so this is very nice conclusion of this theorem or those properties that we talk about it to get it. So it's very quick. And sometimes they ask you to find the inverse of the matrix if it is possible. So when say if it's possible, you check this one first to see that if it's possible. Then we are going to have a method using this determinant to get the inverse of a matrix. I talk about it, and next time. So there is going to be, we already talked about a couple of methods to find the inverse of a matrix. We are going to have another one. This new one using the notion of the determinant. So we talk about that one, and then we put them together, and we have a new method to solve a system of equation. We call it Kramer rules. Kramer is a British mathematician, and that result. So it would be very important. We get 2 questions on that one. Okay, I try to make another, another recording for you by the end of the week. Tomorrow, probably tomorrow night or Sunday morning, Saturday. So that we have that's very important. I need another recording, full recording to be able to talk about it. So that will be 2.3. And then we are done with chapter 2 and we are on our target. This week, chapter 2. Okay, so get this done. Just have a look at the sum of the problems in 2.2. You'll be surprised. Some of them are quite interesting. Then I will, over the weekend, I will, because of the next test, I think it's going to March 3rd or 2nd. I'm not so sure about it. It's going to be maybe 2nd, a week on Monday. So I post the practice test for you over the weekend. Okay, so that you get practice to get to that one. And for the practice test, we usually post a sample, another sample, we call it take-home quiz. It's not like the take-home quiz that you did. That was the actual quiz. Okay, this is just would help you with 2 points. So because we want to have you have 2 samples. One is the practice test, and the other one something extra point if you like. It's just 2 points, but it's useful. That give you more opportunity to practice, okay? So get this done over the weekend. You get that practice one, and we give you a couple of sections from next chapter. We are going to prepare you for future. So it's going to be Euclidean space. You may have seen it. If you have done calculus 3, you may have seen it over there, but we are not going to assume that. And we go over some of the things that we need to be able to prepare for the vector spaces, okay? So take care of this, and by the end of the week, as I told you, you must be done with chapter 2. I posted 2.3 by Saturday. I have a number of the exam at the university tomorrow. We may not be able to do it. Okay, have a good one. Take care. If you need anything, email me. If you want to come to a Zoom meeting, email me first, then I will wait for you. Have a good one. Bye-bye. Take care.